here we're going to look specifically at something or what's called standard form. Now, standard form is a linear equation form that has the formula ax plus by equals c, where the parts of the formula that change are a, b, and c. Those are the coefficients. We can use this form in order to graph, and one of those ways of graphing is by creating a table. So here, that's exactly what we're going to do. We're going to use the idea behind standard form to write our linear equations in order to graph a table, which is going to allow us to graph points. So what we have to remember is when creating a table, you are simply plugging and chugging the information that you have. And by that, what we're doing is you would choose values for one of your variables and then be able to solve for the other, thus creating your coordinate points. So here are kind of just the three easy steps to remember for creating your table. Is that first you want to pick x values. Now this is very important. X is your independent variable, which means that it is the one that dictates. And when you're dealing with linear, you should use at least 3 values. You need 2 of them to graph and 1 of them as a check. Then you will substitute what you chose for x into the equation given, and that's going to give you y. And thus you always need to remember that you have to write it as a coordinate pair. Okay, that is very important. So what we're going to look at is we're just going to look at a couple different examples so that you can get a rough idea of what we're doing. So here we're creating an XY table. So we've got x and y, and we need at least 3 values. So when I'm working, I like to make things as simple as possible. So usually I like to try and stick with 1, 2, or 0, 1, and 2. Let me space that out a little bit. 1 and 2. And then we're going to use these values to dictate or find their y partners. So what that means is we have to plug these values in for x and solve for y. So the first thing that we have is we have that 5 times 0 minus a 2y equals 7. 5 times 0 is 0, so we need to divide by 2, so we end up getting that y is going to be negative 7/2. Okay? And so thus we get our first coordinate point, and that coordinate point is 0, negative 7/2. Now the second one we have is a 1, and so I'm going to go ahead, I'm going to move these down a little bit just to give myself a little bit more space. Of course, you can set things up the way that you choose, but at least this way you can see. So here we're going to look at 1. So we're going to do the same thing we did above. So 5 but times 1 minus a 2y is equal to 7. 5 times 1 is 5, so I'm going to take this idea and move it to the other side. So 7 minus 5 means I have negative 2y equals 2. Divide everything by negative 2 and we get that y is a negative 1, thus giving us the coordinate point 1, negative 1. Last, I have the value 2, so again I need to plug it in. So 5 times 2 minus my 2y equals 7. 5 times 2 is 10, minus your 2y equals 7. I'm going to go ahead and move it over. So 7 minus 10 gives us a negative 2y equals a negative 3, thus y equals 3/2. So giving us the third coordinate point of 2 and 3/2. So what we need to do is we need to graph these. So I would start with your whole number. So I'm over 1, down 1, so that puts me right here. And then I would graph your intercept because we only have to graph one of those points. And when we look at 7/2, what we know about 7/2 is that it should give you 3.5, and in this case it's negative. So we're not going to move left or right any, Instead, we're going to go down 1, 2, 3.5. So puts us down right about here. And then we use the final point as kind of like a checkpoint. So a checkpoint works like this. First, we're going to go ahead and connect our dots because you only need 2 coordinates in order to graph. So go ahead and connect them. I'm choosing to use a ruler. Of course, you wouldn't have to. A checker point is a point that should then still fall on this line. So we're looking at the point 2 and then 3/2. So 3/2 here is the same as 1.5. So we're going to go 1, 2 over and then 1.5 up, and what you'll notice is that it does fall on the line, therefore we have graphed it correctly. Let's do it again, but in this case we'll use this equation. So again, we're still going to set up an XY chart. And I would still use 3 points. To show you that you can use any 3 points, let's make them all even. So we have 0, we've got 2, and 4. So here we need to solve for y. So in this case we're at a y equals, so we just need to plug in. So this is going to be 0 plus 2, which equals 2. Gives us the coordinate point 0, 2. Then the next one is a 2. So here we're going to have 2 plus 2 equals 4. So this gives me the point 2, 4. And then last we're going to have 4 plus 2 gives you 6. So we have the point 4, 6. Again, you have 2 points that you can graph with and 1 to check your work. So we've got the point 0, 2, so we're not moving left or right any, but we're going to go up 2. Then we have the point 2, 4, so we're going to go over 2 and then 1, 2, 3, 4 from that position. Again, we're going to go ahead and connect our dots to draw our line. So here we're going to connect them through. And then we're going to go ahead and use our last point as a checker point. So we need to go over 4, 1, 2, 3, 4. And from there we're going to go up 6, 1, 2, 3, 4, 5, 6. And if you look, you can see that it falls on the line, so we have done it correctly. Alright, let's look at another one. So here I've got that 2y equals x. So there's a couple ways that you could approach this. The first way is we could choose y values and solve for x. Or the second way is we could rearrange to be a y equals equation, which means we're going to then choose x values. Either way is going to get you the same result. If you want to leave it as is, then you could still set up your xy table. Only in this case, I'm going to shift my table this way slightly. Again, we want at least 3 points, so I can still choose x values, and so we can go 0, 2, and 4. And then, again, we would be solving. So here we're going to have 2y is equal to 0, so y equals 0. So this is the point 0, 0. Then we also have that 2y is equal to 2, so divide everything by 2, and y is 1. And then we have that 2y is equal to 4, divide everything by 2, y is 2, and thus we have our coordinate points. So however you choose to do it, you're still going to end up with an xy table. So here we go ahead, use 2 of them to plot. So we're going to plot the point 0, 0. And then the next one, we've got 2, 1, so over 2 and up 1. Just like before, we're going to go ahead and connect our dots here. because that is our linear line. Remember, arrows on the end signify that you are going on forever in both directions. And then we're going to use this last point here as a checker. So we've got 1, 2, 3, 4, and then we're going to go up 2. So notice it does fall where we're supposed to be. So again, we've done it the way we need to. Alright, last but not least, let's go ahead and look at this last one. Again, we can create our XY table. Now here I have a fraction. So I want to be a little bit clever when I'm choosing values. First I'll choose 0. But if I want to get rid of the fraction so I don't have to worry about using it, I want to take into account the fact that the denominator here is a 5. So one value that I may choose would be 5 because that would help get rid of it. And the other thing that I may look at is I could look, say, at -5. So let's go ahead and see how this works. So here I'm going to have 2/5 times 0 minus 3y is equal to 5. Multiply by 0 says it goes away, so divide by -3 and we get that y equals -5/3. So that is our first point. Then I'm going to have my 2/5 times 5 minus a 3y equals 5. Notice my 5's here will go away. Leaves me with 2 minus 3y equals 5. I'm going to move this 2 over. So here you get -3y is equal to 3. So y is a -1. And then last but not least, we would have the negative. So here we're going to again have your 2/5 times a -5 minus 3y equals 5. Again, these cross, but the one thing that you want to keep in mind or not forget is that you had this negative here. So when we multiply, this becomes a -2 minus 3y equals 5. So when I move the -2, I add. 5 plus 2 is 7, so this is -3y equals 7. So y is a -7/3. So with this, the first thing I would do is I would graph my whole points. So here I have the point 5, -1. So 1, 2, 3, 4, 5, and down 1. And then we kind of need to know a rough value. So I have my 5/3 here, which is roughly the same as -1.6 repeating. And then I have my 7/3, which is going to be roughly the same as 2.3 repeating. Again, it's negative. So I have the point 0 and then little more than 1.5. So 1 little more than a half would put it right about here. And so here I would go ahead, just like before, you want to connect your dots. And so here we'd go ahead and do just that. Again, your arrows go on the end. And then we have this last one that we can use as a checker. So it's at the point -5 and then roughly -2.3. So 1, 2, 3, 4, 5. And then we have 1, 2, and just slightly above it. And so there you have it. So all of our checker points have worked. All of our coordinates have given us a linear line. And we've used 4 different examples here to demonstrate creating a table of values based on an equation given and then graphing those values. So if you have any questions, please let me know. Otherwise, enjoy your math, relax, be creative, and I'll see you next time.